Okay, so for this video, we'll be looking at how to find the reaction constant of the equation. We're continuing from the past paper question that I was doing in the previous video about how to find the order of the reaction. Right? So let's look at the question. Specifically, the question that we'll be doing is question 1II. And what it says is that what is the value including units of the rate of concentration? So we're going to find the rate of concentration of the equation, right? So how we would go about doing this is that we would use the rate constant equation, and the rate constant equation is the initial rate of the equation equals to the rate constant multiplied by the molecular concentration of the two reactants, the molecular concentration of the two reactants, and you also put in the order of the reaction for both of these reactants, and you also include the proper unit as well. So I'm just going to write this out to show you. Oh, and another thing as well, when you're doing these type of questions, when you're doing this, what you need to do is that you're going to choose an experiment, right? Choose one of the experiment from the table above, right? So for example, we choose an experiment 1. Once you choose that, you ensure that you use all of the values within that table. No, ensure that you use only the values within that experiment, right? So for example, the initial rate of reaction is going to be that. So example, for the initial rate of reaction, you ensure that you use the initial rate of reaction of only experiment 1. The molar concentration of sodium sulfate, you use that. Molar concentration of iodine, you use that only in experiment 1 only, right? So I'm just going to write that out. And another thing as well, just write that out first. Okay, another thing as well, one thing to take into consideration as well is that the rate constant, what we're looking for, right? It has a, wait name again. Yeah, I'm just going to, let me just wait name again this first. Okay. Right. Oh, it's not rate constant. The rate constant is K. K right there. Multiplied by B Y. Right. All right. So this is the equation that we're going to be using. This is rate constant equation. Reaction rate constant equation to be specific. Yeah. This is the equation. Rate is standing for the initial rate of the reaction, right? This is the solution. This is the, yeah, initial rate of reaction. These are the reactants, and A and B is the reactants, and you're supposed to put in the value of the reactants. Wait, let me just do that now. Oh, it's not. Wait, let me just. All right. Okay, so let's put value again. I think. Yeah, so that's the value. So the value, I just realized that I could have just scrolled down, but anyways. Yeah. So this, remember that we're using experiment 1. Remember that we're using experiment 1, so we're using only the values from experiment 1. So the value, this is the initial rate for experiment 1.4 exponential to the power of -5, right? Reactant constant, we don't know the constant of the constant as yet. So yeah, all right, then you have 0.0, oh yes, 0.038, 0.038 moles per liter. Was it? I'll just, okay. There's supposed to be, I think there's supposed to be some stuff here. I'm just going to scroll down afterwards and then write it. Moles per liter. And then remember that in the previous experiment, remember that in the previous video, we found out that the order of the reaction, all right, I should have said this before, but the order of reaction for the X and Y on top right here is standing for the order of reaction for sodium sulfate and iodine. And in our previous video, we found out that the order of the reaction was 1 for each. And I'm just going to give a simple explanation on how to find the simple version of how to find the order of the reaction again. But I did like a more detailed video on that, and did a more detailed video on that on how to find the order of reaction. So you guys should check that out when you have the time to get a full understanding of this. Yeah. And 0, 6, 0, 2, 1, right? And oh snap. Yeah, I forgot that. Please do not forget the units. Units are very important and you will be marked on the units as well. Right, so let's just check what is supposed to be there. Right, so it's -1, -I. So it's -I for there. Yeah, -1, and snap, the units for initial rate as well. All right. Again, please do not forget the units. Those are very important. 1, -1, snap, moles per liter squared. Okay, this that right there is supposed to be moles per liters, moles per liter. Yeah, yeah. I just so, anyways, yeah. Right, so we're putting our values. Obviously we don't know what's the value for K as yet. We're trying to solve for K, right? So yeah, what we'll be doing now is just we're going to multiply the reactants, multiply the reactants, and then afterwards we're going to use the answer that we got for that and then cross multiply so that we can get K on one side. So let's just do that now. So when you multiply the reactants together, you're going to get this. K equals to 0.00228, 0.0228, right? And 2, yeah. And equals to Now what we're going to be doing is that we're going to cross multiply. Again, we want k on one side because we're solving for k. So we need k by itself. So how we're going to get k by itself is cross multiplying. How you're going to do that now is that you multiply this value by itself and anything more, no, divide, I should say. Yeah, divide. That's okay. You're going to divide this by itself, right? And anything that you divide by itself is going to obviously be equal to 1. Yeah. Two, right? So obviously equals to 1, right? So, and then you're going to have this now. You're going to have your initial rate of reactant multiplied by the answer that you got when you multiply initial rate of reactant divided by the answer that you got when you multiply the reactants, right? Reactants being sodium sulfate and iodine from experiment 1. Mm. Okay. And one important thing as well, if you look at the values over here, you can see 2. This is because when you multiply this by this, you're going to get, well, this and this together will give you 2 moles. This, 1 mole and stuff like that. So yeah. Right. So what is this? 2. Like that. Right. So yeah. And now when you do the equation, now when you do the calculations for that, it would come. Now when you do the calculations for that, it would come to A equals to oh, 6 and 4 0 3 5 4 0 3 5. All right, so for this, but I'm going to explain the moles part afterwards. Moles per liter. -1 for that square. No, that's square. All right, so that is the answer. I'm going to write it out better. Like when you look at this now, you can sort of you realize that this equals to that. All right. To explain, right, before, right, let me just do it the simpler way. You realize that moles here, moles here. When you put that into that, you're going to get a negative. All right. To explain better, right? This mole is supposed to be, let me just show you. Supposed to be that over 1. This is moles per liter Q over S, right? S. And this is supposed to be the same. This is kind of supposed to be the same, but you're going to have 1 at the bottom. But the thing is that when you're multiplying fractions, you have to ensure that the second fraction that you're multiplying is flipped over. I don't remember the specific word that you use for that, but the second fraction is supposed to be flipped over, so it's going to be 1 over that 2 over that, right? And when you do that equation, you're going to find out that the answer is going to be 1 more that. This is 1, this is to the power of -1 here. And then you're going to have L, going to have S of negative. Yeah, so yeah, that's how you find the weight again. That's how you find the units for here, right? And to write, I'm just going to write this out better because I don't think you can fully see what's the answer for the equation. So 3, 5 moles. One. And the one of the easiest what you guys could do is that you could remember about certain order of reactions, like the order of reaction for this equation is a second order reaction, and how we know about the overall order of reaction for this equation is that when you multiply both the orders of reactions from both the order of reactions for the two reactants, that will give you the overall order of reaction for the equation, right? Yeah, and different order of reactions for the rate constant gives you different, it shows you what's the unit, what's the what's the answer for the unit that you would, yeah, what's the answer for the unit that you would get for the rate constant, right? For first, I think for first order reaction, I think it's, no, I'm not going to wait him again. I'm not going to sort them that. I don't remember the specifics, like what's the unit for first, what's the unit for first and zero order reactions, but they have a specific unit. They have a specific unit for the rate constant. So yeah, and that's here. So yeah, that's it. This would be the answer for the question for question 1 part I. Yeah. And this is how you find the units. This is how you find the unit for the unit of the answer. Yeah, the unit for the rate for the constant, the rate constant of the equation and the answer for, yeah. So yeah, just to recap, like this is the equation that you would use, the rate constant, the reaction rate constant equation to be specific. Rate equals rate constant multiplied by the reactants, which would be sodium sulfate and iodine. Ensure to put the proper unit and ensure to put the order of reaction for both reactants here. And then one other thing as well, ensure that when you choose the experiment that you're going to be using, ensure that you will only use the value from that experiment that you have chosen, right? So reactant, right? Initial rate of reactant, we put it here. For sodium sulfate, put that the value for sodium sulfate here for experiment 1 only. For iodine, value for iodine here for experiment 1 only. So the initial rate for experiment 1 only, right? So yeah, and then you multiply the two reactants. Ensure you put the proper units here. Multiply the two reactants. Ensure you put the proper units. After you multiply the two reactants, you want to get K by itself. So you carry over this part. You multiply this you divide this by itself, divide this by that. Anything that's divided by itself will be equal to 1. When you divide the initial rate of reaction by that, it would give you the answer for the rate constant here. And over here now, when it comes to how to find out the units for the rate constant, when you look at this, like this here is up here, that, and then you just, yeah, it's It's pretty easy. All you need to do is just to, what do you call that now? Is just to, is just to practice. Yeah, when it comes to chemistry, the most important thing is to practice the equations. And so yeah, that's it for this other. Oh, I forgot one thing as well. Um, I said I was going to explain the Saturday. I did this already in my previous video, but the simplest way how to find the order of reaction for an order of reaction for a substance here, you just look at the clear all drawings. Simplest way to find the order of reaction for a substance, you look at, for example, we're trying to find the order of reaction for sodium sulfate. You look at the values, two different values for sodium sulfate, the same two different values that are very close to each other for sodium sulfate, right here. So, and if you're on anything that you're able to multiply this first value by to get the answer for this, if you're able to multiply, if you're able to use that, what you multiply by here for the same, all right, for experiment one, right? If you anything that you multiply experiment one value sulfate by to get that you can use to get experiment two sulfate value by, if you're able to use that same number to multiply the initial rate for experiment one and you get the answer for experiment two initial rate, that means it's a first order reaction, right? But if you have to square the value if you have to square the number that you multiply the first order by, specifically, if you have to square it when you're multiplying for the initial rate to get the answer for the second experiment initial rate, that means it's a second order reaction. If the values for the reactant here change, but there's no change here, that means it's a zero order reactant, right? So yeah, that's about it. I'll be doing the next question for the next video next time. Let's do this.